Where is it? Okay, guys, can you see my screen now?
Yeah, we can.
Okay, thank you.
Yeah, I can see it.
Okay, let me just pick the last slide that we did. What was it, that introduction? This one. Okay, guys, so last time we introduced data analysis with R. And what we did, basically, these are just introduction bit. And we said, we highlighted the steps involved in data analysis. We said it involves data collection, data wrangling, data cleaning, EDA, analysis, data visualization, and report writing. And during the session, what we did, we learned how to set your working environment in R. We learned how to install R libraries or packages. Then we learned how to import data into R. We did some exploratory data analysis, data visualization, data cleaning. This is how we set our directory. You can go to YouTube, you'll see how we did them. Get WD was to find your current working directory, then set WD. Inside the bracket, you set the path. You just copy paste from your computer folder, wherever you are working from. Then we looked into how to install our packages. Install the packages, then inside the bracket, you name the package you want to install. Then after installing the packages, what you do, you call the packages now. You load them into your environment by stating this library, then inside the bracket, you state your package. Then we proceeded and discussed about data importation in R, and we said R supports a variety of data files like CSV, XLXS, SAV, CSV, XLS. This comes from Excel sheets or Google Sheets or Excel. Then SAV files come from SPSS. And we saw how to import data into R. We said you use library read, then read.csv_csv. You enter the path. This is when you're importing CSV files. When you're importing XLS files, you do read Excel, then read Excel. Then we looked into some exploratory data analysis where you can find the shape of your data, the structure, the names of your columns, summary, the tail, the head of your data, number of columns, number of rows, basically the shape and some other data characteristics in your data. And we said exploratory data analysis, it summarizes the main characteristics of your data. And we said this is important step because when you are about to build your predictive model, you must first understand your data. You must understand the data types. You must understand these other features. They will help you in knowing what analysis to perform. Then we used visualizations to explore our data, and we said visualization can be classified into three broad scope, which we have univariate visualization, bivariate visualization, and multivariate visualizations. And yeah, you can find the code that we did from there. Then we proceeded to data cleaning. This one Jerry introduced, and he talked about select function, and he also talked about selecting observations, and he also talked about how to deal with missing data. Then he also talked about list-wise deletion, then imputation. The code can be found on Jeremiah Katumo's GitHub repository there. Okay, so now today, what we want to discuss is about data cleaning. data cleaning, feature engineering, and target engineering. And remember, guys, last time I told you about some visualizations, how you can name your bar plots, how you can list the values on top of your bars. And I also said we'll discuss multivariate graphs. I never did that. So today I was to do that bit of multivariate analysis, multivariate graphs, and do a little bit of data cleaning. Then Jeremy will proceed to discuss feature engineering and target engineering, which is a very crucial bit. This is the most crucial bit. After that is when you'll develop now your predictive models. You have to structure your data into a very good format, an ingestible format, a consistent data. You must have a consistent data. So maybe if I can begin, I'll begin by showing you something here. Can you see my screen?
Yeah.
Okay, so those who are just getting into the meeting, welcome. And I was just giving a recap of what we discussed in our last session. And I said in our last session, I told you guys there is a way you can name your bar plots, right? You can list the values of your bar plots. Remember, bar plots we said is used for univariate visualization. You're trying to visualize the distribution of a single variable. Say you want to know like something like gender. You want to know in your current study what gender constituted the highest number. And we just plotted the bar graph without the values in the visualization. So today I was to show you how to do that. So I'll do that straight away. Let me import some data here. Remember data importation, you come to import data set, you choose there, then you browse for your data. My data is in a folder named data sessions. I'll use this one, insurance.csv. Once I click import, you can choose to click import or copy this code, then cancel. Omit this, you can copy. When you run this, you'll see this data here. It will be shown on this pen here. You can see our data. This is insurance data that I've just loaded here. It is data from some insurance company. They recorded the age, sex, BMI, number of children, smoker, region, and the charges someone is likely to incur. The charges that these persons incur. So today, let me show you how you can plot, then label the bars. I'll omit this one. This one is unnecessary here now. Let me start with this. I'll start with this. Start with one without these entries. So I can show you guys. I code as I explained to you. I'll remove this other bit. Then I'll name this one. This place should contain your data. DF just means your data frame, insurance. Then aesthetics, I said, means your X and Y levels axis. So we are trying to study the relationship of a single variable, which is now sex or gender. Then geom bar. This is how you plot a bar graph. You must call it from geom_bar. Then let me do out without this one first. And let me also do out with this one. So if we run this, this is the bar graph you obtain. Can you see here? Okay, I believe you all see it. So if you look at this graph, it doesn't look very much appealing. So we can do something, we can trick it. We can give it a blue color, then give it some black border to make it very much appealing. So to do that, we said inside your geom bar, you come and fill these arguments. Say fill equals to, I used cornflower blue. Then to give it borders, you say color. I've said I want black color. If I run that, you can now see we have blue bars with black borders. So basically that is what we did, and we also did something about labels, labs, which specifies the labels. Then you can add title, say distribution of gender. If you run that, you can see your title. Other labels that you can add are like the X. X you can say is now sex, or we can label it as gender now. Let's run, then and Y. Let's label it as frequency. If you run that, you can see your X and Y labeled correctly. Now, this is what we did last time. So I told you guys there is a way you can, if you look at these bars, you can't identify which one is the highest. There is this close proximity, so you can't tell which one is the highest. So it's a good practice to label your graphs. You can label with the numbers that these bars represent. So to do that, this is the code for it. I'll show you guys. Labeling your bars. So you first come and select this variable here. So you do what is called piping. So I described a new variable, df is insurance, then count sex. This count, what it does, it counts the number of frequency each gender appears. So count sex. Then afterwards, you just do the ggplot. Then in place of your insurance data now, you'll use this new data frame, df. Then aesthetics, you insert your X, then Y, you insert N. Then geom, you just fill all these as we did. You remember these two, fill and color, are for color, and the borders then start is identity. Then geom text, aesthetics label equals to N, V just next 0.5. If you run this, let's see. You can see now on your graph, we have labels. We have 676 for male participants. We have 662 for female participants. So that is how you add labels on your visualization. Okay. Now let's do something about multivariate graphs. We said multivariate graphs, what it compares is the relationship. It's a single graph, but it has more than two entries. It can take up to 3, it can take up to 4 entries, and so on and so forth. And remember, we said you use a visualization or a graph or a chart, you use a simple one that you can explain. And if you use a very complicated one, you must ensure that your targeted audience is one that can understand it. Okay, so let me do this one. Here, what I did, this is ggplot, then I called this data insurance. Insurance is just the same data that we used. Then on my x-axis, I want age. On my y-axis, I want charges, then color, sex, geom point. Remember, we said geom point is used to plot a scatter plot. So we'll receive a scatter plot. with X as age, Y as charges. Then within that same plot, we can communicate which gender does each point represent. So that is a multivariate graph. So let's run it and see. If you run it, you can see you have charges, then age. Then on your legend here, you can see the